Hello everyone, and a very warm welcome to this webinar hosted by PV Tech in collaboration with Huawei. My name is Ben Willis and I'm the Managing Editor of PV Tech. I'm delighted to be here today to introduce what promises to be, I'm sure, an informative discussion on the future of energy management for Europe's commercial and industrial enterprises. This webinar comes at a critical juncture for European businesses. Energy costs have surged in recent years, fueled by geopolitical tensions, supply chain disruptions, and the ongoing transition away from fossil fuels. For C&I enterprises, which often operate energy-intensive facilities, these rising costs are not just a financial burden, they are a direct threat to profitability and long-term viability. At the same time, the EU's ambitious sustainability agenda is reshaping the regulatory landscape with stricter requirements for energy efficiency, renewables integration, and carbon neutrality. Businesses that fail to align with these policies risk falling behind, both in terms of compliance and market competitiveness. The question is no longer whether to adapt, but how to do so in a way that ensures resilience, competitiveness, and compliance in the years ahead. Against this backdrop, the need for innovative energy solutions has never been more urgent. Today's webinar will explore how next-generation solar and storage technologies are empowering businesses to meet these challenges head-on. Huawei, a global leader in digital power solutions, is at the forefront of this energy evolution, and we are delighted to have the opportunity today to hear its insights and expertise. One of the key highlights of today's discussion will be Huawei's 150 kilowatt high-power string inverter, a groundbreaking solution designed specifically for large-scale C&I applications. We'll also delve into Huawei's advanced liquid hybrid cooling energy storage system, which leverages innovative thermal management technology to extend battery lifespan while ensuring safety standards that exceed European grid codes. Throughout the webinar, we'll hear real-world case studies that demonstrate the tangible benefits of these integrated solutions, from reducing operational energy costs to achieving accelerated returns on investment. These examples will illustrate how Huawei's technologies are driving meaningful change across Europe's C&I sector. I'm delighted to welcome our speaker today. Ilias Papadopoulos is a technical leader at Huawei with a decade and a half of experience in the renewables industry, encompassing PV engineering, C&I energy systems, and large-scale grid-connected projects. He's ideally placed to be our guide through today's topic. As always, with our webinars, we really value engagement from you, our audience, so please send in any questions you have for Ilias via the questions tab on your screen, and we'll do our best to include them in the discussion. Thanks for joining us today. I look forward to an engaging and informative session. So let's get started. Ilias, over to you. Thank you.
Thank you very much, Ben. So hello, everyone, and thank you for joining us today in this very insightful webinar. I will start by sharing my screen, and I will let me do this. Okay, so as Ben told us before, my name is Ilias Papadopoulos, and today I will be presenting on behalf of Huawei Digital Power. We're going to have an exclusive deep dive into breakthrough solar and storage technologies that are reshaping how commercial and industrial enterprises approach energy management. This webinar is focused mainly on this scenario, the commercial and industrial applications, where we clearly see the strongest growth, the most demanding technical requirements, and at the same time, the most attractive business cases. During the next 45 minutes, I will walk you through how the market is evolving, what challenges C&I customers are facing, and how Huawei's PV and energy storage solutions are already delivering real, measurable value today. So Here's the structure of today's presentation. We will start with a short introduction to Huawei to understand the scale, the strategy, and why Huawei Digital Power exists as a business unit. Then we will look at global and European industry trends, especially the role of energy storage on them. After that, the core part of the webinar, we will focus on Huawei C&I solution, first for the PV, and then in detail for energy storage systems. Finally, I will show you some real project examples, some service models, and close with a summary before the Q&A from you. So let me begin with a short introduction to Huawei. Huawei has a vision, and Huawei's vision is very clear: to bring digital technology and to every person, every home, and every organization for a fully connected and intelligent world. Huawei operates today in more than 170 countries and regions with over 208,000 employees globally. What is extremely important, especially for a critical infrastructure like energy, is that 54% of Huawei's workforce is dedicated to R&D. This means that Huawei is not just a short-term product supplier. It is a long-term technology company building platforms that must operate reliably for many years in the field. Today, Huawei technologies connect more than 3 billion people worldwide, and the same mindset of reliability, security, and scale is applied to digital power. This slide shows something that really differentiates Huawei from many other players. Over the last 10 years, Huawei has invested 1,249 trillion RMB in research and development. In 2024 alone, R&D investments reached 179.7 billion RMB, which corresponds to 20.8% of total revenue. Huawei has ranked among the top 6 global companies in R&D investment for 8 consecutive years. This continuous investments is the reason Huawei leads in power electronics, digital control algorithms, grid interconnection technologies, and long-term reliability. For customers and investors, this directly translates into bankability. So Huawei's sustainability strategy is not just marketing. It is measurable and audited. By the end of 2024, Huawei solution helped generate over 14,000 billion kilowatt hours of green energy, supported net zero carbon parks, protected nature reserves, and of course connected remote population through energy and ICT. In parallel, Huawei has received global sustainability awards, including the Energy Globe and EcoVadis Gold rating. This matters because sustainability is no longer optional, it is becoming a regulatory and financial requirement. Of course, Huawei's long-term investment approach is also reflected in global recognition. Huawei has been ranked among the top 100 global brands, the top 10 most innovative companies in the world, and we are a certified outstanding employer for multiple consecutive years. For customers, this means continuity, capability, and long-term partnership. Now, let's focus especially on Huawei Digital Power, where, who combines power electronics with digital technologies. The objective is to enable transformation from high carbon energy systems to low carbon system, and finally to net zero carbon energy system. This is achieved through green power generation, such as PV and in some cases wind, energy storage, EV charging, smart distribution network, and a digital energy management platform. The key point here is integration, not isolated components. Huawei Digital Power research and development is truly global. We have power electronics research in Germany and Canada, algorithm and topology research in Sweden, electric drive research in Japan, and of course, large-scale product development centers in China. More than 10,000 employees work directly in digital power with over 60% in R&D. This global footprint ensures that products are designed not just for one market, but for real operating conditions worldwide. Now, let's have a look at the broader industry context. At Conference of the Parties 28 and 29, global commitments were very clear. By 2030, solar and wind capacity must triple. The energy storage capacity must increase by 6 times. This tells us something very, very important. Renewable without storage are no longer sufficient. Solar and wind growth will continue, but energy storage is the key enabler for flexibility, stability, and of course, economic optimization. Now, in Europe, we are seeing two transitions happening at the same time. The European Green Deal focuses on decarbonization, energy independence, and of course, resilience. The digital decade focuses on automation, data, and of course, intelligent infrastructure. Energy systems must now be low carbon, digital, flexible, and secure, of course. This is exactly where digital power solutions become critical. In this slide, we can see clearly an important shift. In Europe, PV installations continues, but growth is slowly slide. Meanwhile, energy storage, especially in C&I and utility scale, is booming now. The C&I storage market is expected to grow rapidly and become one of the main application scenarios by 2030. This is where business cases also have are strongest today. All these business cases. Let's now transition from industry trends to Huawei's solution for the commercial and industrial sector. There are three main forces driving enterprise energy transformation. First of all, carbon neutrality. CBAM, carbon pricing, and ESG reporting are directly impacting operating costs. Secondly, we have the business economics. PV plus storage has reached cost parity and in many cases offers payback periods of 4 to 6 years. The third is the energy access and reliability. We have grid constraints, outages, peak demand issues. All of this force enterprises to secure controllable energy supply. Together, these drivers makes PV plus ESS a strategic investment and not just an energy project. Here, we see multiple business models already applied globally, from maximum self-consumption to time of use optimization, peak saving, grid reinforcement, frequency regulation, to full off-grid applications with a payback period from 2 to 5 years across different countries and industries. Huawei follows a one-fits-all architecture. The same design philosophy applies from residential to C&I Lite, C&I Pro, and of course the large C&I at medium voltage. This reduces engineering complexity, simplifies O&M, and of course allows easy scalability. Let's, deep, let's go deeper to the scenarios. For example, for smaller commercial sites, Huawei offers hybrid inverter and modular ESS storage solutions. These systems support plug-and-play installation, fast commissioning via application, remote operation and maintenance, and of course, flexible expansion. This solution is ideal for small and medium-sized enterprise, retail, and some light industrial customers. After the C&I Lite, we have to move to the C&I Pro and Max, which are designed for larger, more demanding commercial and industrial sites. These are real commercially available products already deployed in large-scale commercial and industrial projects. And let's start from the PV side. At the core of the solution, we have Huawei's high-power string inverters, including Sun 2150K MG0 and sun 5150K MD0. These are currently the world's largest power C&I string inverters designed specifically for large rooftop, industrial plants, logistics centers, and of course, commercial campuses. The advantage of this inverter class is not only high efficiency, but also system simplification. And what I mean, by using fewer high power inverters, we are reducing the number of AC and DC cables, the number of protection devices, and the overall balance of system cost. At the same time, this inverter integrates advanced safety functions such as module-level insulation monitoring, arc fault detection, and fast fault isolation, which are very critical in large-scale commercial sites. Now, let's move to the energy storage system, which is really the heart of profitability in C&I projects. Huawei offers the world's first C&I smart hybrid cooling ESS with configurations at 107, 161, and 215 kilowatt hours. And we are waiting for an upcoming model of 241 kilowatt hours next year. Now, what makes this ESS different is not only capacity, but how it operates. The hybrid air and liquid cooling design intelligently adapts to operation conditions, allowing higher round-trip efficiency, better temperature uniformity across battery cells, and significantly longer battery lifetime. From a business perspective, this translates up to 5% improvement in round trip efficiency, around 2% more usable capacity, and of course, 2% better state of health over time. This number may sound small, but over 10 years of operation, they directly convert into thousands of euros of additional revenue per system. On the right side of the slide, we can see the charger, which completes the whole ecosystem in C&I solution. Huawei's liquid-cooled fast chargers combined with energy storage enable a high-power EV charging without requiring immediate grid upgrades. This is extremely important for a commercial sites such as logistic hubs, parking facilities, retail centers, and of course, some fleet operators. By combining PV plus ESS and charger under a single intelligent control system, Huawei enables multiple operation modes. As we saw before, self-consumption, time of use, peak saving, frequency regulation, and even off-grid operation. All of these coordinated through intelligent scheduling and smart design for the design, which optimizes energy flow and automatically based on prices, load profile, and of course, grid conditions. Finally, at the bottom of this slide, I want to emphasize to three or four pillars of this solution. First, the safety, the proactive safety. Features such as directional gas exhaust, top explosion venting, 5-level ESS protection, and ultra-fast shutdown times are designed to prevent incidents before they escalate. Second, it's the premium quality. We are using automotive-grade cooling components, more than 15,000 hours of real site verification, and maintenance-free coolant designed to ensure the long-term reliability. And third is the profitability, higher profitability, meaning higher efficiency, higher usable capacity, seamless on and off-grid switching in milliseconds, and factory prefabricated deployment. All of these contribute to faster payback and, of course, lower project risk. This is what we mean by one fits all, not one product, but a fully integrated system, scalable from hundreds of kilowatts to multi-megawatt commercial and industrial applications. Huawei C&I scenario has shipped more than 100 gigawatt of smart PV globally and has ranked number one worldwide for 8 consecutive years. More than 100,000 uh, enterprises are already using Huawei solution to reduce their carbon emission and energy costs. Reliability is proven through real-world deployment. Huawei inverters have been validated in deserts, as you can see, in floating PV, in high altitude plateaus, and of course in high humidity coastal environments. With over 15 years of stable operation and an annual failure rate below 0.5%, reliability is not theoretical, it is measured. On this slide, we focus on one of the most critical components in any commercial industrial PV system, the inverter. In C&I projects, inverter selection is not only about efficiency, it directly affects safety, grid compliance, installation costs, operational reliability, and ultimately project profitability. Huawei approaches inverter selection by starting from the customer's real needs, not just from a nameplate power. These are six key dimensions that we consider. The first one is safety. The Sun 2150K MD0 inverters integrates PV ground fault protection, arc fault detection, rapid shutdown, and module level insulation monitoring. This is especially important in large rooftops and industrial sites where fault detection speed, speed that we can detect the fault, can make the difference between a minor incident and a major outage. The second dimension is the efficiency. This inverter can reach up to 98.8% maximum efficiency. But more importantly, it maintains high efficiency across a wide operating range. This means more energy converted into usable energy over the full year and not just ideally laboratory conditions. The third dimension is the balance of system, BOS. By using a 150K inverter kilowatt, fewer units are needed for the same installed capacity. This can reduce the AC cabling, DC strings, protection devices, installation labor, and of course, the overall system complexity, as we talked before. In many rooftop projects, this alone delivers 5 to 10% balance of system savings, and we are analyzing later on this also dimension. The fourth dimension is operation and maintenance, O&M. Huawei integrates module level riser detection, allowing insulation issues to be identified in early stages. This reduces, of course, troubleshooting time, minimizes downtime, and lowers O&M costs throughout the system lifecycle. The fifth dimension is reliability. Huawei's inverter platform is designed for long-term operation with verified reliability of 99.999% availability, close to 100%. And this is not theoretical. It is based on large-scale deployment and long-term field data. And finally, the sixth dimension is grid friendliness. This inverter delivers very low harmonic distortion with THDI below 1%. This ensures compatibility with sensitive industrial loads and compliance with strict grid codes, even in weak or congested grids. When we combine all these dimensions, safety, efficiency, O&M, BOS, grid performance, and reliability, we see that the inverter is no longer just a power conversion device. It becomes a value creation component. This is why the 150K inverter is positioned as an all-arounder for C&I applications. It reduces risk for EPCs, improves bankability for investors, and of course, maximizes long-term value for end customers. And when this inverter is combined with Huawei's intelligent energy storage and digital management platform, the result is a system that is not only powerful, but also safe, stable, and high profitability over its entire lifetime. Let's see now Huawei, how evolved inverter safety since 2016, from FCI and rapid shutdown, the RSD, to module level insulation detection, connector temperature monitoring, and ground fault protection. Safety is proactive with Huawei and not reactive. This can protect both people and, of course, the property. Huawei applies four internal quality processes covering design, testing, supply chain, and, of course, service delivery. As a result, global availability exceeds, as we said before, 99.999%. And this is very, very important. In a real project here in Athens, in Greece, a 400 kilowatt project, Huawei's 150K solution reduced BOS cost by over 10%, mainly through reducing cabling and the use of fewer inverters. This, of course, directly improves project economics. Huawei improves energy yield through advanced MPPT multi-peak scanning, faster dynamic response, and built-in PID recovery. Together, this improves life cycle yield by up to 4.5%. Transition now from product to solution sales by quantify the LCOE reduction, levelized cost of energy. This is the key to the success. Let's take as an example 1 megawatt PV plant in which we can save one inverter with the use of 150K. We reduce the AC cable cost by 5%, and of course, the O&M cost reduced by almost 50%. This can bring higher revenue and, of course, lower total cost of ownership and reducing the levelized cost of energy of 1 megawatt plant by 20%. Before we go deeper into specific technologies, it is important to pause and ask a very simple question. How do we actually choose a commercial and industrial energy storage system? Because very often storage systems are compared only based on nameplate capacity, which is measured in kilowatt hours, let's say. But in reality, capacity alone tell us very little about how much value the system will actually deliver. In C&I applications, what really matters is usable energy, lifetime performance, and of course, risk management. Let me explain a little more what I mean. The first and most important criteria is safety. Energy storage system operates with high energy density, often in close proximity to buildings, people, and of course, critical assets. Therefore, safety must be designed at cell level, pack level, and system level, including electrical protection, thermal protection, and of course, gas management. The second criteria is the round trip efficiency. Every percentage point of efficiency directly affects, of course, the revenue of the system, of the project. A system with higher efficiency delivers more usable energy over every day, which compounds into significant financial impact over the years. Of course, the third criterion is the usable depth of discharge, not theoretical DOD. In some systems, advertise, let's say, high capacity, but restricts the usable range to protect the battery. What matters for the customer is how much energy can be used safely and consistently over the entire lifetime of the project. The fourth criterion here is the state of health over the time, the SOH. A storage system is not a 1 year asset. It is a 10-year or more year investment. The rate of which capacity degrades directly affects long-term revenue and, of course, the payback of the project. Fifth criterion is the system availability and maintainability. Downtime always costs money. So systems that are easier to monitor, diagnose, and maintain deliver more value, even if their initial cost is slightly higher. This is very important. And also, finally, the sixth criterion is integration capability. In C&I projects, storage rarely operates alone. It must integrate seamlessly with PV, EV chargers, building loads, with the grid, and of course, we have to have a single intelligent control strategy. When we evaluate energy storage system using these criteria, the discussion naturally shifts from how big is the battery to how much value does the system deliver over its lifetime. This is exactly the framework Huawei uses when designing its C&I energy storage solution, and it explains why the next slides focus so strongly on cooling systems, efficiency, safety certification, and lifetime performance. On this slide, I would like to spend a bit more time to energy storage cooling because this is one of the most underestimated topic in C&I projects. In reality, cooling design directly determines round-trip efficiency, usable capacity, battery lifetime, safety risk, and ultimately financial return. Traditionally, C&I energy storage systems rely either on air cooling or liquid cooling. Air cooling systems are simpler, but they struggle at high ambient temperature and high power operation. Liquid cooled systems perform better thermally, but they often consume more auxiliary power and increase system complexity. Huawei's approach is different. This ESS is the world's first smart hybrid cooling system for C&I, meaning it intelligently combines air cooling and liquid cooling instead of choosing only one. The system continuously monitors the ambient temperature, internal temperature distribution, the load level, and of course, the operating mode. Based on these parameters, it automatically switches between 6 different cooling modes, always selecting the most efficient option for the specific moment. What does this mean in practice? First, we have higher round trip efficiency. We have 91.3 on the nameplate. By minimizing unnecessary auxiliary power consumption, the system achieves up to 5% improvement in round trip efficiency compared to conventional design. Second is the better temperature uniformity. The hybrid cooling designs ensure that all battery cells operate within a very narrow temperature window. This significantly reduces cell imbalance and aging difference between battery packs. The third is the longer battery lifetime. Better thermal uniformity translates into around 2% higher state of health over the 10 years. That means, of course, more usable energy for longer without premature degradation. The fourth is the higher usable capacity. Because temperature is controlled more precisely, the system can safely operate closer to its, let's say, optimal limits, delivering about 2% more available capacity over its lifetime. For commercial perspective, these percentages are extremely important. Over a 10-year operation period, they translate into thousands of additional kilowatt hours delivered, and of course, therefore, thousands of euros of additional revenue per system. There is also an important safety aspect. Thermal runaway risk is strongly linked to temperature gradients and local overheating. By maintaining uniform temperatures and reacting dynamically to abnormal conditions, hybrid cooling significantly reduces thermal stress and improves overall system safety. So when we talk about Huawei's hybrid cooling ESS, we are not just talking about comfort or design, let's say elegance. We're talking about fundamental enable of performance, safety, and profitability. This is why hybrid cooling is a cornerstone of Huawei's C&I energy storage strategy and why it plays such a critical role in achieving lower levelized cost of storage, which will we discuss further in the next slides. Huawei is the first globally to receive TÜV Prime Safety certification for C&I ESS. And this certifications includes was based on thermal runaway, explosions, short circuits, electrolyte leakage, and of course hydrogen safety. Safety is engineered here at system level, and it is a very important, let's say, aspect of Huawei.
Just
So,
want to chip in on a question there,
yes,
Ilias. Obviously, it's safety's a key consideration, increasingly so, I
yes,
guess, as particularly more storage is installed, in support of PV or in whatever way. But and you talk about how important safety is for your particular product. What would you say is the sort of key advantage of your solution versus those typically
yes.
seen in the market? If you could go into a bit of detail on that, that would be great.
Yes, Ben, that's a very important question, especially for the C&I project, because for the Huawei C&I project, safety is not negotiable. What really differentiates Huawei is that safety is designed as a system, not as a single, let's say, protection function. Let's see on the PV side. We are starting the safety from the module and the string level. We integrate arc fault detection, the rapid shutdown, insulation monitoring, and ground fault protection directly into the inverter. So this allows the faults to be detected and isolated extremely fast, even before they escalate. On the energy storage side, we can go even further. Safety is addressed at cell level, pack level, and of course, system level. This includes some electrical protections, thermal, of course, management, as mentioned before, the ghost exhaust design, and ultra-fast shutdown mechanisms. For example, features like the directional ghost exhaust, the top exploding vent, and the multi-level protection with millisecond response time are not common in the industry, but they are critical for installations that are close to buildings and people. The key point here is that Huawei does not rely on a single, let's say, safety barrier, but we rely on a multiple independent layers of protection. And this is combined with continuous monitoring and, of course, digital diagnostics.
Thank you. That's very clear. Excellent.
Okay,
Thanks.
so uh, let me continue with the presentation. We can see here that the 91.3 round trip efficiency that we are mentioned on a POC test, we proved that it is much higher. And of course, we are a 5.2% higher round trip efficiency, which means lower energy losses, higher, of course, usable energy, and thousands of euros in additional revenue per system over, of course, its lifetime. On this slide, we will focus on a topic that's often overlooked in energy storage projects. But for me and for Huawei, has a huge impact on real performance. This is the pack level optimization. To understand why this matters, let's start with a simple concept. In a battery system, cells and battery packs do not age, of course, at exactly the same rate. Small differences in temperature, internal resistance, or usage history cause some packs to degrade faster than others. In conventional energy storage system, all battery packs are charged and discharged together, as they were identically. This creates what is known as the short Planck effect. The entire system with this is limited, but the weakest pack. As a result, the usable depth of discharge is gradually reduced, and of course, available capacity decreases faster than expected. And last, the energy is left unused inside the system. Huawei's approach is fundamentally different. With pack level optimization, each battery pack is monitored and controlled independently. Charging and discharging are dynamically adjusted based on the real-time conditions of each pack. This means that the stronger packs can continue to operate optimally, while weaker packs are protected from overstress, let's say. Instead of forcing all the packs to follow the weakest one, the system adapts continuously its operation. What is the practical result on this? First, we have 100% usable capacity, which becomes achievable at system level, not just for one day, but throughout the system lifetime. Secondly, the capacity fade is slowed down because no pack is overcharged or over discharged unnecessarily. The third, of course, is the round trip efficiency, which improves because energy is not wasted compensating for imbalances between packs. From a business perspective, this has a very clear impact. We have more usable capacity, which means more energy shifted per day, more peak saving capability, and of course, more revenue from every installed kilowatt hours. Over a 10-year operation period, pack level optimization typically delivers several percent more usable energy compared to conventional system. This can translate into thousands of additional operating cycles and, of course, significant additional revenue without increasing, of course, the system size and avoid augmentation plans. Just as importantly, pack level optimization also improves safety by preventing individual packs from operating outside their optimal limits. Thermal stress is reduced and long-term reliability is improved. So when we talk about Huawei's pack level optimization, we are not talking about just a control feature. We are talking about a core value driver that turns theoretical battery capacity into real bankable energy. This concept also explains why Huawei can confidently combine high depth of discharge with long lifetime. And of course, it sets the stage for this next slide where we are going to look the thermal design and the state of health of the system. We're going deeper into this, the thermal design, because temperature management is one of the most decisive, let's say, factors for battery lifetime and financial performance. All lithium-based batteries are extremely sensitive to temperature, not only to absolute temperature, but also to temperature differences inside the system. In conventional energy storage designs, cooling is often uneven, as you can see on the slides. Some cells or packs operate at higher temperature than others, creating so-called some hot spots. These hot spots may seem small, just a few degrees, but over thousands of cycles, they have a dramatic impact on battery degradation. In many conventional systems, we see temperature difference of 5 to 7 degrees Celsius between the different cells or packs. This, of course, leads to accelerated aging in the hotter zones and uneven state of health across the whole system. Huawei's approach is fundamentally different again. The energy storage system uses a unique dual-loop heat dissipation design, which separates the cooling circuit of the battery packs from the cooling circuit of the power electronics. This separation is extremely important because power electronics generate heat in a very different way than battery cells. By isolating these thermal zones, Huawei avoids unnecessary heat transfer and maintains much tighter, let's say, temperature control where it matters most. And where it matters most is the cell level. As a result, Huawei system achieve cell temperature differences below 2 degrees Celsius, and even under high load and high temperature, high ambient condition, let's say. Why is this so important? First, the state of health, which improves. With uniform temperatures, all cells age at nearly the same rate. This results approximately 2% higher average state of health after, let's say, 10 years compared to conventional designs. Second, capacity remains usable for longer because no single area degrades faster than the rest, and the system does not have to be derated prematurely. The third one is the operational stability, which of course improves. The uniform temperature reduces internal stress, lowers failure probability, and of course improves long-term reliability. From a financial perspective, this directly, of course, translates into value. A 2% improvement in state of health may sound small, but over a 10-year operating period, it results in more cycles usable, more energy delivered, and of course, thousands of euro of additional revenue per 100 kilowatt hours installed. So this thermal design also improves bankability. For investors and lenders, predictable degradation curves and stable long-term performance reduce the risk and, of course, improves the confidence in cash flow models. So when we talk about Huawei's unique heat dissipation design, we are not talking about mechanical engineering details. We're talking about a core of enabler of lifetime performance, safety, and of course, financial predictability. This is why thermal design, together with hybrid cooling and pack level optimization, forms, let's say, the backbone of Huawei's C&I energy storage strategy. Let's see now the smart PVMS. The smart PVMS covers the full life cycle from the design, which we can design with a smart design in 10 minutes project, to operation, to the forecasting, to optimization, and of course, the intelligent features further improve profitability and simplify the operation and maintenance. I want to clarify that what we really mean by one fits all in the context of energy storage. This does not mean one single product for every situation. It means one unified system architecture that can operate reliably across many different grid and application scenarios, let's say, without, of course, redesigning the system every time. In a commercial and industrial project, energy storage systems are increasingly required to do more than one job, of course. Let's say a system might operate on grid during normal condition, support peak saving and self-consumption during the day, provide backup power during outages, and of course, in some cases, operate fully or partially off-grid. Huawei's storage is designed from the start to support all of these scenarios with the same platform. So one important aspect here is the transformerless architecture. By eliminating the need of an external isolation transformer in many applications, the system reduces cost, reduces losses, reduces footprint, and of course, simplify the installation. At the same time, power quality is not compromised at all. The PCS, the converter of the system, delivers very low harmonic distortion with THDI below 1.5% in on-grid operation and THDU below 2% in off-grid operation. This is extremely important for for industrial customers, let's say, and sensitive to sensitive equipment, and of course, strict grid requirements. Another key feature is the three-phase four-wire PCS with neutral conductor. This allows the system to support unbalanced loads, supply mixed single-phase and three-phase equipment, and operate stably in weak or asymmetric grids. This is major advantage in real industrial environments where loads, of course, are rarely perfectly balanced. Now, let's talk about grid outages. The system continuously monitors grid conditions. When a grid outage is detected, the PCS switches seamlessly from grid following mode to grid forming mode. This transition happens in around 20 milliseconds, which is fast enough to keep most critical loads running without interruption, let's say. In grid forming mode, the energy storage system does not just follow the voltage and frequency, it creates them. This allows the ESS to act as a reference source for the local, let's say, microgrid, stabilizing voltage and frequency even under rapidly changing loads. From an operation perspective, another major advantage is system simplification. We have the same smart logger is used for both on-grid and off-grid application. There is no need for separate controllers, complex, let's say, interlocking or additional external devices. This, of course, simplifies engineering, commissioning, operation, and long-term maintenance. From a business point of view, one fits all means fewer system variants, lower engineering costs, faster deployment, and easier scalability. And for the end customer, it means an energy storage system that is not locked into a single operating mode today, but is future-proof, able to adapt as grid conditions, regulation, and business needs to evolve. This flexibility is the key reason why Huawei's energy storage systems are increasingly selected for complex commercial and industrial projects. So on this slide, we bring everything together and focus on one key metrics, LCOS, the levelized cost of storage. If you remember only one financial concept from this section, let it be this one. LCOS answers a very simple but critical question. How much does each kilowatt hours delivered by the storage system actually cost over its entire lifetime? Levelized cost of storage is calculated as the total cost of ownership, meaning capital expenditure plus operating expenses, divided by the total discharged energy over the system lifetime. So LCOS is not driven by nameplate capacity. It is driven by how much usable energy the system can reliably deliver over, let's say, 10 or 15 years. This is why two storage systems with the same nominal capacity can have different LCOS values. Huawei's energy storage system achieves up to 20% lower levelized cost of storage compared to conventional solutions. And this is not the result of one single feature. It is the result of multiple design choices working all together. First of all, the high round trip efficiency. With an RTE round trip efficiency of over 91%, less energy lost during charging and discharging, and more of the input energy becomes sellable or usable output energy. Second, 100% DoD enabled by the pack level optimization. More of the installed battery capacity is actually used every day throughout the system lifetime. And of course, third, we have a better state of health over time. Thanks to hybrid cooling and uniform thermal design, capacity degradation is slower and more predictable. This means the system continues to deliver high energy output over the years. The fourth is lower operating and maintenance cost. The automated SOC calibration, state of charge calibration, the intelligent monitoring and maintenance-free coolant design reduce manual intervention and, of course, reduce the service visit. Fifth, and closing with this, the lower hidden cost. Simplified installation, transformerless architecture in many cases, and unified control reduce engineering and commissioning costs that are often overlooked. When we combine all these effects, the denominator of the LCOS equation, total discharge energy, increases significantly, while the numerator, total cost, is kept under control. The result is a structurally lower LCOS. Now, let's shift for a quick discussion from energy optimization to new revenue creation by combining energy storage with electric vehicle charging. Across Europe and globally, EV adoption is accelerating much faster than grid expansion. High power charging is becoming a bottleneck, especially for a commercial and industrial side, and fast chargers require very high peak power, often hundreds of kilowatts per charger, but these peaks occurs only for short periods of time. So upgrading a grid connection to support these peaks is often expensive, slow, and sometimes simply not possible. This is exactly where energy storage become a strategic enabler. By integrating an energy storage system behind the meter, the site can charge the battery gradually from the grid or from the PV, and of course, then discharge at high power, very high power, to the EV charger when vehicles arrive. In this way, the ESS act as a power buffer between the grid and the chargers. Huawei solution combine liquid-cooled, ultra-fast chargers with high-power modular charging units and, of course, an intelligent energy storage under a unified control system. This allows charging power of up to 600 kilowatts per dispenser and up to 720 kilowatts with dual dispenser. From an operational perspective, the system uses power pooling and intelligent scheduling. Huawei also supports partners with full lifecycle services, from warranty and remote support to one's on-site commissioning and, of course, supervision and training. We have flexible service delivery models which ensure quality while allowing partners, let's say, to lead their own project. And this is very important for the partnership between Huawei and the customers. These are some real deployments, some basic, not pilots, across all contents. I'm here in Greece. I just put one project here, some case sharing. And here we see the Spain's largest superstore chain, the Mercadona, which is targeting PV capacity of 250 megawatt by 2027. And this expansion is expected to cover 15% of the company's energy consumption. The typical ROI for this PV plus ESS storage is 6.5 years. Another case is Poland's, the fifth largest superstore chain, which have 40 megawatt of PV from Huawei on their 1,000 store. And here we have a typical ROI of 5.4 years, including optimizer, which is very important. Another case, and we are closing with this, it is here from Greece. This is an energy-intensive waste treatment facility with zero feed-in export limitation constraints, and it has the first year of operation, the 2025, reduced energy consumption by 40%. This is extremely high, and it drives the energy transition to every company. Closing, I want to mention that by the end of June 2025, Huawei Digital Power has helped customers generate 1,766 billion kilowatt hours of green power, save 112.4 billion kilowatt hours of electricity, and reduce 890 million tons of carbon emissions, equivalent to planting approximately 1.2 billion trees. To conclude, Huawei Digital Power's commitment to working closely with partners to accelerate a smarter, safer, and greener future. Thank you very much for your time, and I look forward to your questions if we have time to answer them here.
Thank you very much, Elias. That was magnificent. Well done. Lots to take on board there. Lots and lots of detail. I know one of the questions we always get, which actually we haven't had this time, is whether the presentation will be available, which it will, I believe, after this. So
yes.
If you didn't manage to take in everything that Elias told us there, you will, if you're signed up for this webinar, receive presentation to go over at your leisure and look at all that interesting detail that was in there. So thanks very much, Elias. Time for a few questions. Just a general one about inverters, actually, where you started the presentation. In terms of sort of general market trends, there's obviously been a clear shift from central inverters to string, even in large commercial and industrial projects. I guess the sort of thing we're talking about today. Why do you think this transition has been happening and gathering pace, and how do you see how does Huawei see this ongoing evolution in inverters?
Yes, Ben, this transition is happening because the PV projects have changed. In the past, central inverters were mainly chosen for simplicity, and of course, the upfront cost was lower. But today, C&I projects are much more, let's say, complex, and the focus has shifted also to safety. Not only safety, flexibility, uptime, and of course, life cycle, let's say, value. String inverters can offer several advantages, which is very decisive for the project. First of all, we have higher system availability. If, let's say, we have multiple string inverters and one inverter is offline, the rest of the system continues operating. This is extremely important in the commercial sites that cannot afford at all planned, let's say, outages. The second one is the safety. We have a better safety of the system with string inverters, let's say. The DC cables length are shorter, the fault currents are lower, and the advanced protection like arc fault detection, as we mentioned before, the rapid shutdown, can be applied much closer to the source of the problem. And third, we have a better energy yield and flexibility. The efficiency that we have with 150K MG0 is 98.8%, which is much higher than any central, let's say, inverter. And of course, the string inverters handles the partial shading, different orientations, and complex, let's say, rooftops much more effectively than central architecture. Huawei sees string inverters not just the replacement of a central inverter, but as an enabler of intelligent, digital, and safer, of course, PV projects. You are muted. Ben, you are muted.
Sorry, thanks. A question relating to inverters quite a technical one. Does the inverter allow the parallel connection of strings inside the inverter, for example, 3 parallels for each MPPT, eliminating the need for a DC string electrical panel? Is that one that you were able to answer?
So can you repeat the question, because I don't think that I understood it correctly.
Yes. So the question was, does the inverter allow the parallel connection of strings inside the inverter? That was the
outside
question.
The inverter. I mean outside the inverter, probably.
Oh, outside the inverter. Yeah, I guess so.
Okay. This inverter, the specific inverter, has 7 MPPTs, and every MPPT has 3 inputs. So we can use 21 strings to combine. In some cases, we can analyze this option, but it should be case by case, let's say, take it. But in order to have the maximum, let's say, efficiency, we have to use every string as it is.
I see. And on parallels, the 215 kilowatt hour series, how many parallels does that support at most?
If in the scenario that we have a PV plus ESS, we can have up to 20 to 15 kilowatt hour storage. And if we want to use only ESS, we can have up to 50 with 3 smart loggers. And there we need the third party SCADA EMS to control everything, but we can achieve up to 50 cabinets in one system.
And On the third-party EMS, what protocol is required for connecting to a third-party EMS?
We can connect with the Modbus and the IEC 104. All of these you can find it on support.huawei.com. All the details. We have a very let's say big database of manuals, videos, quick guides, and technical guides with step-by-step installation on every aspect of the products.
And on the all important question around warranties, what is the product warranty of the 215 kilowatt hour series?
This is very important, very nice question. This storage, if it is connected to our smart PVMS platform, to the Fusion Solar, as you know it, it takes a free of charge 10-year extension, and meaning that we have a product warranty of 10 years, and it can be extended up to 5 years with charge, let's say. So in general, we are the company that can provide warranty up to 15 years for their storage systems.
Okay, great. Just a couple of closing questions, perhaps zooming out a little bit. I mean, we're hearing more and more about energy storage, and I think one of your slides showed the many kind of uses, the business models, and it's obviously being discussed in many different sort of contexts as a sort of key enabler for the next stage in the energy transition, I guess. But also, more from a sort of business perspective, as something that really most companies are going to have to consider at some point in the not too distant future. I mean, from your perspective, what's the sort of key role that energy storage, in conjunction with PV possibly, but also perhaps on its own in today's energy systems is, especially in the context of what we're talking about today, C&I customers? What's the sort of the value of it, I guess?
Yes, that's a great question and a very hot topic these days. For me, storage is not just let's say about storing the energy. It's about adding flexibility to the whole energy system. Let's say for commercial and industrial customers, electricity is no more flat. The price is not predictable, the cost. So we have volatile prices, grid constraints, renewable generation that depends on weather, and increasing, of course, pressure of decarbonization. Energy storage allows business to decouple when energy is produced from when it is consumed. So in practical terms, this means that we can charge when electricity is cheap or when we have PV production, and discharge when the price are high or when we have, let's say, a demand peaks. This immediately creates some economic value through cost saving and in some cases new revenue streams. At the same time, storage improves the energy security because it helps business right through grid disturbances, avoid production losses, and of course maintain continuity of operations. And finally, energy. For me, energy storage, again, I will say it again, it's a system enabler. Without storage, due to the high penetration of renewables that we have instabilities. So with storage, renewable becomes more controllable and, of course, more predictable. So when we look at energy storage today, especially in the C&I segment, let's say, it's no longer an optional add-on. It is a strategic asset that improves the resilience, reduce costs, and supports the energy transition in a practical and, of course, a business-driven way.
And just as a final one, kind of leading on from that, I mean, there'll probably be, companies out there at the moment hearing your words or similar words said by others, how this is a kind of strategic necessity now, given the direction of travel on all of the things that you just outlined there. But I guess, on the one hand, there are lots of different sort of business models and use cases for these kind of systems. There's also, lots of technology choices as well. For a typical business, considering investing perhaps in a system such as one of those that you described in your presentation, it can be a pretty confusing landscape to understand if it's not something that you're familiar with. What would your advice be on where a company should begin in trying to understand what business model they might want to follow if considering investing in one of these, or which technology combination might work best for them? What would your advice on a starting point be for getting to grips with some of this kind of perhaps quite confusing stuff?
Yes, we have a very different, let's say, scenarios in all over the world. My suggestion is to choose the correct partner, and this is why Huawei provides one-fits-all solutions from the design to the business model and to the installation and O&M. Huawei can be a strategic partner of a customer. It's not easy to make a business model. You have to evaluate a lot of things. Huawei, for example, provides a free tool for designing system and making decision on which, let's say, storage solution you should use and what will be the return on investment of the project using, let's say, maximum solar consumption or time of use or even an off-grid operation, and have a clear image of the project that you want to do, and help you choose the correct, let's say, products and solution, because the solution is the main concept, not only the product.
Great stuff. Well, thank you, Elias. We are out of time.
Thank you, Ben. Sorry for my, I was a little...
That's all right. No, it's all great stuff. I mean, this is all really valuable information and insight that really is the purpose of this webinar today. So thanks again. So we're out of time. We're at the end of today's webinar, which I hope, as I have all found informative and stimulating. As mentioned before, recordings of the webinar and slides will be available after the event. If you sign up, I believe they'll be emailed to you in the next few days. The full webinar and presentation will also be available in full shortly on PVTech's on-demand section, so keep an eye out for that. All that remains is for me to thank Huawei for sponsoring this webinar today, and of course, above all, to Elias, our presenter today. Glad your voice held out through that, Elias. Well done. His contact details, I think, were on the presentation if you want to keep the conversation going. So have a look out for that. This is our final PVTech webinar of 2025. So thanks for tuning in today, and to any others that you've joined us on throughout the year. We really appreciate your ongoing support. So that's it. I and all the team at PVTech would like to wish you a successful and prosperous 2026. Thank you from all of us, and goodbye.